Cassidy will be able to monitor from this tool, again setting up in just about 20 minutes. Everything going according to plan from the International Space Station side of things, getting great views from Dragon of the International Space Station. Look at that, the lights reflecting from the outside of the International Space Station turned on. So Bob and Doug have a very clear view of the International Space Station. Should be entering into an orbital sunrise here shortly. From there, we'll take you through the next few maneuvers, again passing waypoint 1 and going right into that manual flight test. Again, everything here from Mission Control Houston, International Space Station configured for docking. Everything's go from our end. Back over to you in Hawthorne.
All right, thanks, Gary. We're jumping in now with Bob and Doug inside the Crew Dragon. Again, you're able to see what they're looking at on those displays there, and this a view from the Dragon spacecraft itself. You can see the International Space Station continuing to close in. Right now, they're only about 430 meters away. They're going to be quickly passing through waypoint 0 in the next 3 minutes, and they're going to continue their way up to waypoint number 1, which is going to be just about 220 meters out in front of the station itself.
Yeah, and Dragon has a number of relative navigation sensors, items that are used for guidance and control of the vehicle. So right now, Dragon's in a pointing mode that has those relative navigation sensors trained on the space station, with the attitude control system making minor adjustments as it needs to, if there's any roll correction or anything that it needs to perform. And Bob and Doug getting closer and closer to that manual flight test. They looked pretty comfy in those seats for that view right behind them.
Yeah, they are suited up, and again, they get suited up for anything we consider kind of the dynamic operations inside the spacecraft. So anytime that they're either in an approach and docking maneuver or an undocking maneuver, and then obviously at the very start and the very end of their missions, which are probably the most dynamic phases, that launch and ascent, and then that deorbit and splashdown when they come home and splash down in the Atlantic. We are just 420 meters away from the space station, less than a third of a mile. Should be just about a minute and a half until we're passing through waypoint 0, and then Dragon's going to begin a little over 20 minute, about the 25-minute trip up to the docking axis. So this will be waypoint 1. There'll be 220 meters directly in front of the station, and they'll be lined up perfectly with that international docking adapter at the very forward port of the Node 2 module, also known as Harmony, on the space station.
Yeah, and there'll be a small attitude correction there. The navigation and prop specialists on our team will monitor that burn, and then hopefully we'll hear some words from the core to the crew, letting them know that we've had a good course correction towards waypoint 1.
And again, things a little bit dark right now. We should have sunrise in about 25 minutes. And so things will light up as we get closer to that manual flight test, and hopefully by the time we're there, we'll be right in front of the space station itself. We should get some good light on Dragon, and hopefully some views from the station looking straight out at the spacecraft using the cameras that are right next to that docking port on Node 2. And then Bob and Doug will once again take the controls using those touchscreens to maneuver Dragon. They'll do a number of different translational maneuvers, so physically moving the Dragon spacecraft in space. Oh, we're seeing some thruster firings there. And so those are using some of those, we call them the service section Draco thrusters. There's 12 around the lower part of the Dragon spacecraft.
Very cool to see those Dracos firing. They actually use a hypergolic propellant, so it's monomethylhydrazine and nitrox, which very, very handy because you mix those two propellants together and they make fire, which is exactly what you want when you want a reliable engine when you're doing these proximity maneuvers. So nice to see those.
Dragon SpaceX on Big Loop. Approach 0 has started, and the trajectory has converged on waypoint 1. Expect arrival at waypoint 1 at 1322 UTC.
Dragon copies on the Big Loop, 13:22.
So those words from Anna there, confirming good convergence. So what that means is the trajectory of the spacecraft is now syncing up with where waypoint 0, waypoint 1 would be when both spacecraft are moving forward in time. So that means that Dragon will be right where it needs to be, and we're expecting Dragon to reach waypoint 1 about 25 minutes from now.
Yeah, and that still puts us still about 16 minutes ahead of the original timeline. So we're expected to arrive at waypoint 1 at 13:22 UTC, or 6:22 a.m. over here on the West Coast in Hawthorne. And if we continue to track about 16 or so minutes early, we may get to that docking a little bit early as well. Again, we were tracking right around 7:30 a.m. Over here on the West Coast. So we may be more in the neighborhood of about the 7:15, but obviously that just depends on how all of the additional maneuvers go. But Dragon so far moving ahead of schedule in its flight to the International Space Station. We've moved past waypoint 0, so we're inside 400 meters right now, just under 370 meters away from the station. Already converged on its next stop is going to be waypoint 1. And once it gets there, again, the crew is going to jump in and command a hold before they move into their manual piloting test. All right, it is 6 a.m. here in Hawthorne. If you're just now tuning in, the Dragon spacecraft well in range of the International Space Station right now, just 350 meters away. We've stepped through all of our procedures, all of our burns, all of our maneuvers to get Dragon to this point since we launched just a little over 17 and a half hours ago. Dragon was able to make all of its maneuvers to get it on the same orbital plane as the International Space Station, and we've already begun integrated operations between the teams here in Hawthorne and those out in Mission Control Houston, and now we're just really getting into some of the final steps before Dragon makes it to the space station.
Yeah, and on your screen right now we're in orbital night, so the Earth is blocking the sun, but you can see the lights from the Dragon spacecraft. That flashes a light that's right along the forward hatch. Right now, Dragon is in a relative pointing mode that's pointed directly at the space station and making its way towards waypoint 1, which is about 220 meters below the station. The International Space Station, when we're doing proximity operations, has a couple of imaginary gates. They're sort of three-dimensional shapes around the space station for vehicles that are approaching. Right now, we're moving towards a hold just outside of the 200-meter keep-out sphere. And Bob and Doug aboard, currently seated in their spacesuits, monitoring the transition. And when they get to waypoint 1, they'll issue a hold to conduct a manual flight test on this test flight mission.
Yeah, this will be their second manual flight test, and really the second kind of key objective for them to really put Dragon through the ringers. This is a demonstration flight. This is that final test before we certify the SpaceX Dragon to operationally carry full crew complements to the International Space Station. They were able to complete their first flight test shortly after getting on orbit. That one, they focused on changing Dragon's attitude, using the Earth as a guide to put Dragon in a very specific orientation known as local vertical, local horizon, essentially putting it in an orientation the same as a plane flying over the surface of the Earth. So the attitude control of Dragon, just one part of, or really one half of controlling a spacecraft. Now they're going to be testing out the translational maneuvers. So once they command that hold, the first thing that they'll do is align Dragon very precisely with the actual docking axis, and then they'll step through and send a number of commands to the spacecraft through those touch screens, moving it across a couple of different axes. So again, translational means you're moving left, right, forward, backwards, up, down, and that's one half of really controlling the spacecraft, is you have all of these different axes to worry about, both translational and for attitude. So they'll step through those. Depending on how those go, we'll then be able to move in for the final approach.
Yeah, that's right. One thing to consider with a spacecraft is it is a three-dimensional body that's moving in space. So you not only have to control your X, Y, Z position, that up, down, left, right, forward, back motion, but you also have to control which direction you're pointing. So we've alluded to the sim online that starts you off in a skewed attitude. Anytime you're pointed in a different direction, then do those translations, you have extra motions that you need to cancel out in space.
Yeah, I remember the simulation too can show you how deceiving it can be to fly in space, because when you initially look at it and you load up, it almost looks like you're already pointing directly at the docking port, and I just need to go straight, when in fact you need to physically move the capsule down and left and roll it so you're completely lined up, and then change which direction you're pointing. It's just infinitely more complex than just getting in your car and doing a left, doing a right, going forward, backward. You're operating in all dimensions when you're flying in microgravity in a spacecraft. So Dragon doing that autonomously right now. The crew will step in to do some manual control, just to again prove out the Dragon systems for the crew to jump in should they have to. Looks like we're getting some thunderstorms actually on the Earth below. Let's see where they're flying over. We're still over the Pacific Ocean. We just flew over the island of Fiji in this orbital nighttime, about 264 statute miles over a restless planet Earth.
Beautiful to see those views of the planet. Even more beautiful when we had orbital daytime. But we had some really cool shots. There's one point when we flew over the Caspian Sea, saw some really cool clouds there, and I think we also saw nighttime over Japan as we were flying over the Terminator.
Yeah, we're able to see a couple of city lights on the Earth's surface below. We're a little more than halfway through this orbital nighttime. We should be getting sunrise in about 15 minutes from now, and at that point, we will be just about arriving at waypoint 1, so we should be getting sunrise right as Dragon is arriving, just about 220 meters out in front of the space station.
Here's a cool view from the station, station camera. You can see Dragon approaching. We've just got those red and green lights on either side of the capsule. It gives folks looking at the capsule a sense of orientation of the vehicle. And here's a view from Dragon. Dragon's got a number of relative navigation sensors, as well as a couple of cameras that can look forward that will hopefully get some additional views for as we get closer to docking. So here's a good view of the space station. And pretty cool. You can actually you can see the solar panels and actually the thermal radiators there. Here's a great view from a camera behind Bob and Doug. Bob in the right-hand seat in the pilot seat, Doug in the commander seat, or the CDR seat. They've got a display in front of them that's the forward view. It's got some procedural information on the left-hand side that's telling them criteria that they're looking for. Anything off nominal, they could, of course, step in and issue a command if necessary. And then on the left-hand and right-hand screen were actually their piloting controls. So when the vehicle is in an appropriate state to receive those commands, they can just hop in and use those touch-sensitive gloves, issue commands to the vehicle's attitude control system.
Have a little over 13 and a half minutes still in this maneuver. It is really cool to get this look inside. And again, that screen in the middle, you can see the trajectory that Dragon is on. And if they were to just continue, it would eventually take them on a path away from the International Space Station. But at the very top of really their orbital path right now, they'll converge on a point just 220 meters directly in front of the space station. So once they do get to that point, they'll be able to command a hold and have the vehicle essentially hover just a few hundred meters in front of the space station itself. They're moving at a pretty slow pace right now, but again, slow and steady wins the race whenever we're doing these docking maneuvers in close proximity to the station. We have about 13 minutes to go. They're moving at less than half a tenth of a meter per second as they continue to close in.
There's another view from the space station looking back, and there's a brief moment there when we were looking at Doug's display where you could see that same view that we had of the International Space Station. So they have those views from the vehicle overlaid on their displays to give them some awareness of their relative motion to the space station, especially handy if they had to actually step in for manual piloting to dock. Fingers crossed they won't have to do that today, though, and that the flight control system will operate as intended.
Yeah, we'll get the manual piloting demo, and then it'll be handed over to Dragon to do a nice, smooth operated, automated docking. Again, we've not been tracking any issues with the Dragon spacecraft on the whole flight uphill. Been moving through each of these burns a little bit ahead of schedule, running about 16 minutes or so ahead of the timeline as it was originally mapped out.
Yeah, very, very healthy vehicle, this test flight, very little. I'm sure Bob and Doug have a few things as well that they're getting used to. There's only so much a simulator can train you on. I think they had mentioned a little bit of that during the ascent portion. There are a few things that are a little different than what they expected. But just because when you're actually launching on a rocket, that's a different feeling than sitting in a training capsule.
Yeah, can't quite simulate a 9-minute ride on top of a controlled explosion in an office. But as they did give credit to the teams here at SpaceX, the actual piloting of the spacecraft went off exactly like their simulators. And so they're able to do all of that training here in Hawthorne, both in a cockpit simulator and in a full mock-up of the Dragon spacecraft itself, even able to get fully suited, plugged into the seats, go through all of the different systems that they had to get familiar with before they moved into their flight today.
Yeah, you and Jesse actually had a really cool opportunity to step in and see the training capsule. The team that I work on actually gets to help train the astronauts that are coming through, so I've had some cool opportunities to interface with the Crew 1 crew. They've already started their training for the Dragon vehicle.
Yeah, you get the really cool job. I get to come tag along every once in a while. But yeah, it was really exciting to literally sit in the seat where Bob and Doug were as they prepared for this mission. It was really exciting.
Station, it's Houston on the big loop for Chris, crew monitoring. Chris, you can begin to monitor the approach per step 1 of 1.104 Crew Dragon approach and retreat monitoring. I'll be in work.
So heard some cool stuff over the loops there. Looks like Chris Cassidy aboard the station is getting ready to monitor. We'd sort of talked about this earlier, but during the Demonstration 1 mission, the crew aboard the International Space Station had issued commands to Dragon. That's a capability that they have. So
Yeah, so with Chris Cassidy now monitoring, we're a little under 9 minutes away from that arrival at waypoint 1. Let's jump over to Gary real quick for a quick station update, and he can walk us through some of the systems that are going to be in play during this manual piloting test. Gary?
Thanks, Dan. Yes, we're monitoring the approach of Bob and Doug. Now just about 300 meters from station, heading towards that waypoint 1. One of the next milestones here coming up is going to be the manual flight test. Chris Cassidy already getting in position in front of the RPOP. This is the rendezvous software that he'll be using to watch some of the demonstration and the rest of the docking procedures for Bob and Doug as they move in to dock with the International Space Station. Right at about the time of the manual flight test, they will be communicating through the C2V2, Common Communication for Visiting Vehicle. You heard the call on the big loop. That was Joshua Kutrick here in Mission Control Houston, Capcom, talking with International Space Station Commander Chris Cassidy all over the big loop. That was that's an integrated communication loop with space to ground on station, Dragon to ground on Dragon, everybody hearing the same thing. Once we're in position of the manual flight test, C2V2 will transition to receive video as well. We should be getting some great video from Dragon all through the hardware that is on the International Space Station, integrated and linked with the Dragon. Now just inside 300 meters from station, I'll toss it back over to Hawthorne as we go through these next steps, heading towards waypoint 1.
right on. Thanks for that update, Gary.
As Gary said, we're inside 300 meters away from the space station. Should be getting that arrival at waypoint 1 in just about 6.5 minutes. And then we'll see some dynamic action pickup with Bob and Doug stepping in to command a hold to the Dragon spacecraft and then step into their manual piloting test. Just to give you a long look at everything, we were originally tracking the docking just a few seconds before 7:30 a.m. Pacific time. We have been moving well ahead of the timeline, so we may only be about an hour away from docking at this point, as they're moving about 16 or 17 minutes ahead of schedule so far with all of Dragon's maneuvers. We'll consider that initial contact and capture of the vehicle to be that initial docking. After that, though, there are a series of steps that have to take place with the Dragon vehicle, actually done in concert with the station itself, which will do a quick handover of its attitude control systems, and then the soft capture ring on the Dragon spacecraft will begin to retract, and then a series of latches or a series of indicators will tell the Dragon spacecraft when it's ready to start driving hooks, which will secure it very firmly to the international docking adapter on the very forward Node 2 port on the International Space Station. And then once we have docking complete, there will be a series of steps both for the crew on Dragon and for the crew on the International Space Station.
Yeah, that's right. Once docking is complete, the cavity in between the PMA node and Dragon, which we refer to as the vestibule, that is still a vacuum. So we'll do some steps there to bring air in from the International Space Station to pressurize that volume. There'll be a leak check on that volume to make sure that we truly have a good seal. Don't want to lose that precious life support to the vacuum of space. And then, of course, when we pressurize that volume, that area has been exposed to space for a pretty long period of time, and we're expanding a gas into it. So the temperatures will fall in there a little bit. So there'll be a period of time for a thermal hold to wait for temperatures to stabilize and to confirm that the pressure is good. So once all those things are good, then we can hopefully open the hatch, the forward hatch.
Yeah, we do expect it'll take about an hour and a half or so typically before we start seeing hatches opened between the station and the Dragon spacecraft following a docking. And there are going to be two hatches. The first on the station side is the A-Pass hatch. That one will get open first, and then we'll wait for everything just to make sure that, again, we're at an equalized pressure between the cabin inside Dragon and the now open hatchway on the station side before Bob and Doug are able to open up the Dragon hatch. A number of other things are taking place while we're waiting for the hatch opening to occur. Dragon, once it's docked to the space station, will be able to connect via an umbilical to transfer power from the International Space Station, so no longer needing to use its own solar arrays to power batteries and all the systems on board, be able to draw power.
Dragon SpaceX for Approach 1 on Big Loop. Approach 1 and the soft capture ring extension will begin shortly. Command a hold 20 seconds after beginning Approach 1 for the manual piloting demo.
Copies on the Big Loop. 20 seconds after Approach 1, we will command the hold.
Good copy.
And so real quick, what they're referring to there, in about 2.5 minutes, we'll be at waypoint 1, so about 220 meters out in front of the space station. And then, just like waypoint 0, the vehicle able to bypass waypoint 1 and continue on its approach to the space station. The crew is going to jump in 20 seconds after they hear that Approach 1 has started, command a hold, and then they're going to move into that second manual piloting demonstration on board Dragon. So we should see that all start to happen in just about 2 minutes. And thankfully, as promised, the sun starting to come up on both of our spacecraft.
Yeah, they also mentioned the soft capture system. So they'll do an extension of a ring with 3 pedal-like structures on it that are covered in micro switches and sensors. And when we do finally get to waypoint 2 and final approach for docking, those will interface with the international docking adapter and give us a confirmation that we've made what's called soft capture. Now, at that point, the spacecraft may have some relative motion, so that system helps get rid of any of that relative motion before we go in for final closure of the hard capture hooks.
All right, so just a little under a minute to go now. Dragon just about right out in front of the International Space Station. Again, in less than a minute, it'll begin its Approach 1, and then our crew members inside of Dragon will command the vehicle to stop. It will hover, and then they will be able to begin that manual piloting demonstration.
Just about 240 meters away from the space station. We're pretty much lined up right in front of it. along what we've been calling the V-bar, and you may hear that on comms.
We do have a short communications blockage with the space station. We have pretty continuous coverage. We've had pretty continuous coverage getting views from the station cameras, which come down through our higher data rate, our KU band antenna. Sometimes it can actually get blocked by some of the station structure, whether it's solar arrays or other pieces of the station, depending on where the actual TDRS satellite that it's pointing at is located. And it looks like we do have that blockage for the next 5 minutes or so. And then once that clears up and we have a clear line of sight for that antenna, we'll get that video back from the International Space Station. So we're expecting that to come about 28 minutes after the hour, so in about 5 minutes from now.
Ground control teams still certainly have good data to both Dragon and the International Space Station, so they're still able to monitor what's happening, have good telemetry, so different sensors, the velocity of the vehicle, how the prop is doing, if any thrusters are firing, what commands are being sent.
Just had a quick TDRS handover for Dragon, so transitioning between those tracking and data relay satellites and standing by for confirmation of that hold.
Station, it's Houston on the Big Loop for Chris monitoring.
Right, Houston.
Station, in preparation for Endeavour's manual piloting demo, you can monitor now per block Charlie in 1.104, Crew Dragon approach and retreat monitoring.
I'll be block Charlie.
Dragon SpaceX on Big Loop. Expect reconfiguration of the C2V2 return link shortly.
Copy.
All right, so we had confirmation the crew was able to send that hold. They're at right about 203 meters away from the space station right now, it looks like.
Right now, just flying in formation right in front of the space station, which is really cool.
Again, we should be getting the video views from the station itself back in just about 2 minutes from now. But yeah, Dragon holding just about 200, a little over 200 meters directly out in front. They're going to take a few moments to reconfigure C2V2, that common communication for visiting vehicles, to begin getting some higher data rates to get video from Dragon through the station as we begin to step into this near-field manual piloting demo. And just a reminder, Bob and Doug are going to be doing some translational maneuvers, so they're going to precisely align the Dragon with the docking axis, so lining it up directly in the center of the docking target, and then they'll begin to move along a number of different axes through translations, forward, backward, up, down, left, right, just another test of the manual control function on board the Dragon spacecraft. And then once they're complete with that, they'll put Dragon back into automated control and begin to move in towards the final waypoint, waypoint 2, just 20 meters in front of Dragon. So before we start that, we do need to wait until we get that high data rate communication with the station locked back up. Again, should be just about another minute or so until that's in place.
And hopefully when we get that high data rate communication back, we'll also get some views into the cabin behind Bob and Doug. We got a few cool views of that earlier as they were getting closer and closer to station. So if you're just joining us.
Station Houston on the big loop for Chris. Dragon's now transmitting docking camera video. We want to confirm that video and data is updating in the Dragon 2 docking monitor.
Work. Confirm.
Copy, confirm, thanks.
So as I was mentioning earlier, if you're just now joining us, Dragon is now just 220 meters in front of the space station. The astronauts aboard, Bob Benkin and Doug Hurley, have commanded a manual hold. That's to perform a manual piloting test. There is a very nice shot of the Dragon vehicle from cameras aboard the space station. You just saw one of the Draco thrusters there firing, just to keep it in that hold attitude, flying right in front of the station.
Yeah, we have two cameras on the very forward port of Node 2, so right where Dragon's going to be headed following the completion of this manual piloting test.
Dragon SpaceX on Big Loop. C2V2 link reconfiguration is complete. The soft capture ring extension is also complete.
Dragon copies on the Big Loop. Good ring extension and C2V2 reconfig.
So those comms on the Big Loop, the core, the crew operations and resources engineer here at SpaceX letting the crew know that we have a good TDRS link again. Good C2V2 link again. It's common communications for visiting vehicles. And we actually heard a little bit earlier as well comms to Chris Cassidy to monitor this manual piloting test.
Dragon SpaceX on Big Loop, you are go to execute the proximity manual flight test. per procedure, 4.041, and I have the target fuel levels when you are ready to copy.
Your go for 4.041, and we're ready to copy the fuel constraint.
Your 1/3 fuel usage will be 60.9, 2/3 58.9, and terminate 57.9.
We copy 60.9, 58.9, and 57.9. We'll pick up in 4.041.
Good copy, and we're with you.
All right, so they're going to start maneuvering Dragon, again, making some translational maneuvers. We did get some insight that it looks like they're a little bit to the left of the docking axis right now. And so we should expect them to move directly into the center line as one of their first maneuvers. That's going to be their very first maneuver. And then they have a strict list of choreographed steps just to test out moving on the other axes. And we heard the core Anna Menon calling up the expected fuel usage inside Dragon. They're going to be keeping a close eye on that just to make sure they're not overusing the propellant in those flight tests, making sure we still have good margins for all of the approach maneuvers, and then obviously for everything at the end of the mission itself.
Yeah, and the thrusters that we're using here.
Dragon, on the big loop, we are commencing with docking axis capture.
We are following along with you.
So the thrusters that we expect to see firing here would be on the service section or on the trunk. And you'll see some plumes coming out from the shot on your screen.
First part of this maneuver is just to really line them up perfectly with that docking axis. So they were already several meters off once this hold occurred, and so they're making very low impulse commands being sent to those Draco thrusters. Again, as Shiva was saying, there's the 12 around the lower part of the Dragon capsule that they're going to be using, and we're seeing small bursts now.
Yeah, and they actually have a couple of precision modes where they can put in sort of coarse and fine inputs into the vehicle. That's all stuff that they can control off of those touchscreen displays to get the right amount of impulsive thrust into the vehicle. If you're trying to get a little bit oriented to how the vehicle is positioned, that's the nose cone on the top of your screen. So Bob and Doug would be sitting sort of underneath that nose cone and see the pressurized portion of the capsule, and their seats look up into the displays and also would look towards the side hatch, which is currently sealed underneath on the opposite side of where that nose cone is. Very cool to see those thruster plumes.
Yeah, the Kronos and Mission Control Houston actually opened up the iris a little bit on that camera on the space station so we could see these plumes.
And SpaceX Dragon, we've completed the docking axis capture maneuver. We're going to move on to the YZ translation.
Copy, we're with you.
All right, sounds like they've got themselves lined up exactly on the docking axis, so directly in front of that international docking adapter on node 2. Now they're going to begin some lateral and axial maneuvers. So again, just putting Dragon now off the docking axis and to just continue these translational maneuvers. So at this point, we should see them head up to the right and up from this view as they're just making very small adjustments in the Dragon's positioning in front of the space station right now.
And here comes the translation.
We copy.
Yeah, in the data, it looks like we're seeing the 6 thrusters essentially on the bottom of the spacecraft right now from this view, lighting up. So it's going to begin to move them straight up. And it's difficult to tell, but there is a very slow drift upward right now.
Yeah, it looks like they're going about 0.1 meters a second, if I'm looking at this data correctly. So very slow and steady. And they will probably do a quick correction to stop that upward movement. It's a little surreal seeing Dragon so close to the space station. Less than 18 hours ago, I was on the pad at Launch Complex 39A. Now it's so close to its destination.
Yeah, being piloted by humans for the second time already in this mission.
And I would just be too excited. I don't know how Bob and Doug keep this so professional.
It's that test pilot mentality.
Yeah, they both have thousands of hours in aircraft. Both test pilots.
Yeah, both came from military test pilot backgrounds. Bob Bank in the Air Force, Doug Hurley, a Marine Corps aviator.
And then I believe Naval Test Pilot School, so... A little bit overexposed there, but you can still see the thrusters firing.
Yeah, our Kronos working to do that deliberately for us so we can see those thruster plumes from this camera view. We're at a normal exposure, so not able to see those jets into the darkness of space. But when we do overexpose a little bit, you're able to see those thruster plumes coming out of the Dragon spacecraft.
Yeah, it's amazing how the plume has to catch the light just the right way for us to even see that it's happening outside of data. Yeah, and looking at the data now, it looks like we have zeroed out that radial velocity delta. So Bob and Doug cleared out that small translation test that they did. We may get a radio call down here that they've completed the Y direction testing. Now, I know we've mentioned this a few times, but it looks like the spacecraft are totally still right now. And that's partially true. They're still relative to each other. But right now, both the space station and Dragon are going around the world, what is it, about once every 90-ish minutes?
Yep.
Or less?
Once every 90 minutes, seeing 16 sunrises and sunsets every single day. And while our view right now,
We've completed the Z translation, moving on to the Y.
We copy. We're with you.
A copy. So I was a little bit mistaken. They just finished up the Z direction, doing the Y next.
Dragon SpaceX on Big Loop, you have used approximately 1/3 of your prop test budget.
And Dragon copies 1/3 of the prop test budget.
So the Corps letting the crew know how much prop they've worked through. Still have 2/3 of their budget left to do test maneuvers. And of course, any bit of propellant that they're using is just a little bit less margin if they needed to use it for something else. But a good way to exercise the system, see that manual piloting works as intended, and I'm sure for them to have a chance to provide some feedback on how manual piloting actually felt in space and how the control felt.
yeah, a big part of their job for this mission is really to not only put the vehicle through its paces, but to take a lot of detailed notes and mental notes that they're going to be passing along to any future crew members flying on board Crew Dragon. As we've talked about, the simulators have been a pretty good guide for how the actual manual piloting goes, but things like the ascent up to orbit were quite a bit different from what they expected. And so they're just taking all of that in, internalizing it, and a big part of their job once they come home is to pass that along to all of our upcoming crews, one of which is targeted to launch just about a month after they come home. That Crew 1 outfit of 3 NASA astronauts, Victor Glover, Mike Hopkins, and Shannon Walker, and a Japanese astronaut, Soichi Noguchi, will be aiming to do that flight a little bit later this year. So going through the paces right now, looking at our data, I think I made the same mistake you did, where I assumed them going up would be the y-axis. It looks like that was actually their z-axis, and the y now them moving to the right. So we're seeing some small shifts. They're continuing to use up a little bit of their prop budget. We heard they're already a little past 1/3.
Yeah, it's actually something interesting about both aircraft and rockets. When you consider the coordinate system, what we refer to as the x-axis is usually the one that goes through the nose. So in the case of Falcon 9 and Dragon sitting on top of each other, the x-axis would have been pointing through the nose cone going up. Can be a little bit counterintuitive. And then actually in aircraft, the z-axis usually points down, depending on whether you use European or American coordinate systems and the type of aircraft you're working on. But important for both Space Station and Dragon to be on the same coordinate system as they do this eventually as they step into the approach maneuvers here towards waypoint 2. Dragon will be using its relative navigation sensors, again, for relative position to the station, to make sure that it's on the approach, within the bounds of the approach corridor going towards the station when we get to that after this manual piloting test.
Should be getting to that shortly. This manual piloting test was slated to last about 25 minutes. As we have been running ahead of schedule today with all of Dragon's maneuvers, we could be looking at a docking only about 25 or 30 minutes from now. So once they're done with this manual flight test, they'll turn control back over to Dragon's flight computers, and they'll resume their approach, which had actually already started automatically before the crew issued a hold command to the vehicle. And then they'll press in to arrive at waypoint number 2, at which point the teams will do a final go, no-go for docking. They'll depart that 20-meter hold point, and it should be just about 5 minutes following that departure until we get contact and captured.
Yeah, and the crew right now are seated in Dragon in the pilot and commander's seat. Both of them are suited for what are relatively dynamic maneuvers, and they'll continue to be suited until we have confirmation of good hard capture on the space station. So right now, just interfacing with the touchscreen displays, testing out manual piloting. Hopefully secretly a little bit giddy to be piloting a spacecraft.
I mean, before they had launched, Bob Behnken had referred to this mission as every astronaut's dream, getting to launch in a new spacecraft, putting it through its paces. He and Doug Hurley, with those test pilot backgrounds, testing out a new spacecraft has to be as good as it gets. But they're still stepping through this manual piloting. We should have just a few more minutes until they're done with this Y-axis translation. And then they'll be able to turn command back over to Dragon, which will return itself to the docking axis, and then begin that approach into waypoint 2.
Yeah, and as a look ahead, so when we do transition into that approach, Dragon will autonomously go towards waypoint 2, which is just 20 meters away from the forward international docking adapter on node 2. And it'll hold there. That'll give the ground team some time, both in Houston and here in Hawthorne, to do a go, no-go poll, make sure that the vehicle still looks healthy, make sure that everyone on board the space station and of course on board Dragon.
SpaceX Dragon, we've completed with the translation maneuvers. We're going to pick up with the closure maneuver.
We copy. We're following along with you.
All right, sounds like they're done with their translations. They're going to start moving it back to the docking axis, put us right back on the center line, and then we're going to resume that approach into station.
Dragon SpaceX, you have used 2/3 of your prop test budget.
I can copy 2/3 of the budget. SpaceX Dragon, that completes the closure maneuver.
We copy. Closure maneuver complete.
That will move on to 4.041, section 4.
We copy and concur.
All right, so our manual flight test has been completed. We're standing by for them to now resume approach 1. So to move in from that waypoint 1, we're already inside of the keep out sphere at this point. Dragon's holding just 176 meters from the space station, and pretty soon they're going to be approaching.
Dragon, that completes the manual piloting demonstration. I only had to twist Doug's arm for 2 or 3 minutes to get him to allow me to deactivate the piloting controls.
We copy. Excellent. Thank you. And with that, we ask that you, from the display used for manual piloting, please go to audio settings and adjust a gain setting for seat 1 or 4. And in addition, we would appreciate any handling qualities evaluation of the proximity piloting possible.
We've completed the gain setting adjustment for seat 1, and I'll turn it over to Doug for the handling qualities quick look. SpaceX Dragon on the big loop for the handling qualities. It flew just about like the sim, so my congratulations to the folks in Hawthorne. That flew really well, very crisp. It was a little sloppier and wide, just like we saw in the sim, but all the other axes, as well as closure and opening, were all just as per.
Excellent to hear. Thank you.
That kind of gives you an indication of sort of how the design process works. You know, Bob and Doug have had lots of opportunities to test this out and sim it and give their feedback. And pretty cool to hear that their sim experience was very similar to what they saw actually on orbit. Just, I think you said 170 meters away from station right now?
Yeah, we're just 176, and I imagine as a spacecraft designer, that's exactly what you want to hear, is the way that I trained you in it here on the ground is exactly how it performed once you're there for the real thing. So the second manual piloting test in the books, Bob and Doug putting Dragon through its paces. Now we're time to put it all to where we get to our endpoint. We're ready to get Dragon docked to the International Space Station.
Dragon SpaceX on big loop. The ground will be resuming approach shortly. We do plan to hold briefly at waypoint 2, so reminder that crew visors down are not required until the ground is preparing to command the final approach.
Thanks, Dragon. We copy. We'll hold at waypoint 2 for a pause, and then we'll get our visors and launching command.
We copy.
And station, it's Houston on the big loop. As you've heard, Endeavour is resuming its approach to waypoint 2. Chris, you can monitor now for step 2. That's step 2 and 1.104 Crew Dragon approach and retreat monitor.
Copy. Step 2 will work.
Pretty cool view of the International Space Station from Dragon. This would actually be overlaid, or rather their controls would be overlaid on the displays on top of this view. And we got to see some pretty cool views from behind. Actually, there's a view right there. You can see the station on their displays. Visors up, Doug in the left seat, Bob in the right seat.
Yeah, so at this moment, Dragon is going to be resuming the approach. As we heard them informing the crew, They're going to have that one final hold when they're just 20 meters away. That's going to be at waypoint 2. We're expecting it to be a brief hold while the teams all tag up and do a final go to move in for docking. Getting a great look at the space station itself. The docking port is right in the center of our screen. You can see another spacecraft currently docked to the space station, the Japanese HTV spacecraft currently docked to the Earth-facing port. One of those common berthing mechanisms also on Node 2. So Dragon will be the second vehicle to be docked to the Harmony module once it makes its final approach. And it's moving in right now. Again, just to give you an idea of how quickly they're moving, they're going at about 0.3 of a meter per second right now. And so if you're having any trouble with that docking simulator online, remember to just slow things down a little bit and your chances will go up exponentially. We just passed 140 meters away. We'll get our live video comm back with the space station momentarily. As soon as we do, we'll bring you back up there. But for now, Bob and Doug continuing to fly in. They're just 135 meters away.
Station on the big loop in step 2. Review of steps 3 and 4 is complete. Crew on the International Space Station is ready for docking.
Station Houston on the big loop. We copied the review of 3 and 4 complete. International Space Station ready. Thank you.
Expedition 63 Commander Chris Cassidy giving the report. Station is ready for docking.
Yeah, and you can see the trajectory of the spacecraft. There are small corrections that are happening. So as we get closer and closer to station, we're trying to stay within those 2 corridors, which are shown coming out of the docking port that we're going towards. That little dot, I think, was the 20-meter hold point, so that's where we expect there to be the spacecraft holding right in front of the International Docking Adapter. There'll be a go, no-go poll. The ground teams have worked hard over the past probably years to come up with a set of what we call flight rules. So those are technical constraints, items that we look for, that if any of those criteria were violated, then we have a rule that we've predetermined, gives us guidance to say whether we could approach or not. So far, our vehicle has been very healthy, but technical ground teams will all do their due diligence to make sure that it's still safe to approach.
We're inside 100 meters, continuing to close. Again, we're going to have a short hold at 20 meters. Teams will just do a final check, and then they'll give Dragon the go. We're expecting it to be pretty brief. We should get to that hold point in just about 4 minutes, moving at our current pace.
I think you can see a meatball and American flag on that on the spacecraft. The NASA logo, of course, referred to as the meatball. I think there was some spirited discussion about the meatball versus the worm during ascent. And you can see those logos. That structure on the fairing structure is actually what the Super Dracos are housed in. Of course, all of those are deactivated now, only used for launch escape during the ascent portion. Nose cone right at the top of the vehicle. And you can see sort of the sealing surface, those four circular slots right underneath the nose cone within that red ring are the forward bulkhead Dracos. That's what we were using while we were conducting all those burns, the 5 burns to get to this point. Right now, we don't have a reason to use those. We'll only be making small attitude corrections with the service section Dracos. And you can see the service section actually pretty clearly here too. There's a black portion and a white portion sort of separated by a fin. The black portion is solar panels, solar cells that'll charge Dragon's batteries. And the bottom side, the white portion, is actually a thermal radiator that's used to keep the spacecraft nice and cool. Of course, the avionics and the cabin, making sure that Bob and Doug are comfortable inside.
Looks like we're getting a shadow cast. We are just 60 meters away, continuing to close in, just about 40 meters to go until we're at that hold point. Should get there in just over 2 minutes. Meanwhile, teams in Hawthorne and in Houston doing their internal go, no go for docking. They're going to get all the teams pulled. Once everyone's go, we'll be able to give Dragon the final go ahead for the vehicle to autonomously fly in and dock with the International Space Station. Should be coming up on waypoint 2 arrival in just about 1 minute, 45 seconds. At this point, it'll be 20 meters away from that docking port. The International Docking Adapter number 2 attached to pressurized mating adapter number 2 at the very forward end of the Harmony module.
Right there on the, right around the center, you can see the forward hatch. It's got a window in it. You can see a couple of handles, and there's some features that look sort of bronze-ish. Those are the pedals that we were talking about earlier as part of the soft capture system. So pretty wild, too, to see. We're so close that we're getting shadows from the station on Dragon. Wow.
And we're getting these views of Dragon's approach from 2 cameras that are right next to that docking adapter. And the movement's a little jarring at times. These cameras are being commanded by a person at the Cronus console in Mission Control Houston, and they send some very basic function commands to the camera, which it then executes automatically. And so they're continuing to follow Dragon in, so we do thank them for their diligence to give us these views of this historic moment as we are just less than 30 meters away from docking.
Right above the NASA meatball logo, you can see 3 of the service section Draco thrusters.
That's right, 12 in all. So the 4 of those clusters spread around the vehicle, used for a lot of the attitude control and any small translational maneuvers like we just watched Bob and Doug execute with their second manual flight test.
Yeah, and actually oriented in a way, too, where if you were to lose some of those thrusters, you still have redundancy and control in those axes. That's part of the reason why they're sort of at the angles that they are.
All right, so we should be getting to waypoint 2 right now. So it looks like we do have that hold.
Dragon SpaceX on Big Loop. The ground is go for approach 2. We will be enabling the resume shortly. As a reminder, ensure your visors are closed prior to Dragon's departure from the waypoint. And once Dragon is inside the crew hands-off point, retreat and breakout are not permitted. And for your awareness, we have sunset in a little less than 8.5 minutes.
Copies all on the Big Loop. Go for docking.
So Doug on Spacecraft confirming their go for docking. They're going to put down their visors. Got some instructions there about the crew hands-off point that we had talked about earlier. That's a point where we don't want the crew issuing any commands to the vehicle. It's about just about 2 meters away from the docking adapter. I believe the number is about 1.7 meters.
Station Houston on the Big Loop. Houston and station are now go for docking. Chris, you can monitor per steps 3 and 4. 3 and 4 in 1.104 Crew Dragon approach and retreat monitoring.
Copy steps 3 and 4.
Next Dragon on the Big Loop. Our visors are down.
Copy, visors down.
With the crew confirming their visors down, we should see the final approach resume.
Station Dragon on the Big Loop. We are inbound from approach 2.
Copy, inbound.
Station copy.
And we're going to be racing that sunset. The approach has resumed. Dragon closing in. We're inside 20 meters. And yeah, that crew hands-off point should come up in about 3 minutes or so. Right before we get that final docking, it comes about 20 seconds prior, or just about 2 meters away from the station still. And that's just the crew not issuing any abort commands. At that point, it would be too late, and so any aborts would be executed automatically by Dragon itself. So we're closing in at less than 1/10 of a meter per second at this point.
You can see the service section Draco is just doing all these very small, minor attitude corrections. Really, the autonomous docking system at work, making sure that the vestibule and the soft capture system is lined up with IDA-2. It's the International Docking Adapter. You can see much more clearly there the hinge mechanism for the nose cone. Those 4 black circles are the forward bulkhead Dracos, not to be used at this time. And then, of course, the pedals of the soft capture system. Wow.
Dragon on the big loop. We're inside 10 meters. We cannot make out the docking target, but we do see the outline.
We copy and concur, 10 meters.
All right, we're less than 10 meters away. Again, we're closing at that rate of less than 1/10 of a meter per second. We should be just about 1 minute, 45 seconds away from docking.
There is a center line camera right in that middle, so you can see where the forward hatch is, and right in the middle of that there's a window, and there's a center line camera that is aligned with the center of the vehicle and the center of the docking mechanism. So that is what the autonomous docking system is using to line up with sort of a cross hatch, cross target on the docking port. Again, the forward docking port on PMA2, or the pressurized mating adapter.
And we are just 5 meters away. Again, we're racing that sunset. This Dragon continues to close, 4 meters to go.
Those shadows of the space station on the vehicle. Yeah, you can actually see the centerline camera pretty clearly there. Sort of with the contrast of the sun right now.
3 meters to go. Two meters. We are inside the hands-off point, the chop, the crew hands-off point. 1 meter to go. Soft capture complete.
Dragon is soft capture confirmed. Stand by for retraction and docking.
Standby.
And we just heard it, soft capture. We have docking, that coming at 7:16 a.m. Pacific time, with the station and Dragon flying 262 statute miles right over the border between northern China and Mongolia.
You saw a little bit of motion there of Dragon. That was that relative motion that the soft capture system is damping out. Once that motion is clear, then the soft capture system will be retracted, and Dragon will go for hard capture.
Again, if just now tuning in, That soft capture, that docking coming 7:16 a.m. Pacific, 10:16 a.m. over on the East Coast. Dragon and the International Space Station were flying 262 statute miles right over the border between northern China and Mongolia. So that soft capture ring now going to retract. It's one more step on the way to docking complete.
Copy. Please take it on board.
Yeah, and so the next step here is once the soft capture ring is retracted, there are 12 latches that we refer to as hard capture latches. Those are what will really create that pressure-tight seal between the Dragon spacecraft and the International Space Station. So once soft capture is complete, and I believe we'll get that call from our core here, Anna, then we'll get confirmation of hard capture, and the crew, of course, aboard have this information on their displays, so they'll also see indication of hard capture complete. And once those two steps are done, then that's docking complete.
That's right, and we're expecting to hear some words from everybody. A pretty monumental moment. I mean, for Doug Hurley, he's returning to where he last docked almost 9 years ago on the very last space shuttle mission, now commanding the very first commercial spacecraft to deliver astronauts to the International Space Station.
That's got to be cool for them. They've mentioned quite a few times that they're best friends. Our favorite dads in space, as we've been calling them. This has got to be really cool for them. It's got to be really cool for their families too, watching this.
It looks like we have another quick handover. We'll get that video back shortly. We're about 75% complete already with that retraction. Once that retraction is completed, we'll keep an eye out for the 12 ready to hook indicators. Once those are ready, those 12 hooks will begin to engage, and that'll securely attach Dragon to the International Space Station.
Yeah, so right now the vehicle confirming that the soft capture system is deployed correctly and is fully retracted. And then once the soft capture system is fully retracted, that'll set up the vehicle to put in the hard capture pins. There's 12 of those around the docking ring, and that's what creates that airtight seal between the Dragon spacecraft and the International Space Station. The volume between, which we refer to as the vestibule, is currently not pressurized. Of course, it was just exposed to the vacuum of space until literally minutes ago, about 4 minutes ago. So just waiting for the vehicle to get that.
Dragon SpaceX, ring retraction complete. Docking sequence is holding for MCS reconfiguration.
All right, so we see those ready to hook indicators are lighting up green. So we should be just about to step into those 12 hooks beginning to engage to get that secure mate between Dragon and the International Docking Adapter on the space station.
Wow, right now those two vehicles are flying together. They are attached to each other.
It's been just under 19 hours since we lifted off. We're actually at about 18 hours, 58 minutes, and 42 seconds. So we promised about a 19-hour ride up to station, and we made it just a few minutes before that. They were able to dock a few minutes ahead of schedule. We were tracking them to still take about another 10 minutes, but able to step through all of their burns about 16 minutes ahead of schedule and get us to where we are now. If you missed it just a few moments ago, that initial docking coming at 7:16 a.m. Pacific, 10:16 a.m. over on the east coast of the United States, and they were 262 statute miles flying together over the northern border of China and Mongolia. So really exciting. We're just waiting for this docking complete to be confirmed. We'll expecting to hear some words, obviously, from the crew on board and all the excited teams down here who are just waiting for this moment. And then it's time to start getting Dragon integrated into the station. There will be an umbilical that will get mated, and that'll allow Dragon to flow data and power into the station systems, and then it'll be over to the crew.
Endeavour and station at Houston on the big loop. MCS is configured. We're proceeding with hook driving.
All right, and they did a quick, so the motion control system onboard station now back under those control moment gyros, so handed over from the Russian thrusters, and Dragon now given the go to drive those hooks. We have to do that changeover of attitude control before we drive those hooks, as the Russian thrusters a little bit more dynamic in their control of attitude, and if you had a thruster firing while you were starting to drive those hooks, that could miss a line. So going over to the smoother control moment gyros on the US side, now controlling the attitude on board the station, and those hooks, those 12 hooks on Dragon, about to start driving.
Right now, Dragon and ISS attached, just flying off the east coast of China, just underneath Japan. Attached to each other, we recently passed over to the orbital night, so we're on the currently the dark side of the world. And actually, we're lucky enough to see soft capture happen just as we were crossing over the Terminator line.
And if you're wondering what you're looking at, this is one of the cameras on the very outboard part of the Japanese experiment module, looking back in towards the very front part of Node 2, where Dragon is currently docked. We are in an orbital nighttime, that's why everything is so dark, but you're looking at Dragon. It is horizontal to the ground, so the hatch part is right where that green light pretty much is. You can see the nose cone still illuminated above it, and it is currently attached to an international docking adapter on the International Space Station.
And inside that capsule are Bob Behnken and Doug Hurley, first astronauts to fly on a privately developed vehicle up to the International Space Station. Both test pilots got to do some fun tests today. Have a few more steps before they can actually get aboard and ingress to the International Space Station. And that's what we heard over the big loop, that transition, which allows us to then proceed with hard capture.
And we're seeing the first set of hooks, so the first 6 out of the 12 are now closed, 6 more to go.
Again, there are 12 of those along the ring. And that helps us ensure that we have an airtight seal. It is vacuum around them right now, so we want to make sure we're keeping all of that valuable life support in the vehicle. Now the combined ISS Dragon vehicle.
Meanwhile, inside the capsule, Bob and Doug also standing by for this hard capture to complete. And once we have that docking complete call, they'll be able to start stepping through a number of procedures to get them ready to move into the International Space Station. They'll get the go-ahead to doff or get out of their suits, and then they'll have some activities on the Dragon side to prepare for the hatch opening. Chris Cassidy will mainly be working on the station side to pressurize the vestibule. So as Shiv has talked about, the space between the Dragon capsule and the space station was exposed to vacuum, and even after this tight seal has occurred, we'll still be at vacuum inside. So we'll actually open up a valve to supply air from the station side into that space between the Dragon and station hatchways, and they'll get it up to the same ambient pressure that we'll have inside of Dragon and on the station itself. They'll wait for it to thermally balance out, make sure we don't have any temperature swings as we're bringing it up from vacuum. So probably from a very cold temperature up to about 72 degrees that they have in their cabin temperature on board the station, and then we'll get the hatches open.
Dragon SpaceX, hard capture complete. Stand by for docking completion.
Now that hard capture is complete, so that's confirmation of those 12 latches to create that airtight seal. Now that's complete, the umbilicals from the station side will interface with the Dragon vehicle umbilicals, and that'll provide power and communications through space station directly to Dragon. Pretty much the whole way up, Dragon's been using a combination of batteries and its solar cells pointed at the sun to make sure that it has enough electrical power for the journey up.
And we're just standing by now for that umbilical to get mated, and that's going to, again, as Shiv was just saying, start the power and data transfer between Dragon and the space station. They've been transmitting data through RF radio frequency on the way uphill, and during the final approach, this will give a hard mate, basically a wired LAN connection between the Dragon spacecraft and the International Space Station itself, and then also being able to draw power from the station systems using those great big solar arrays that are used to generate all of the electricity for systems on board the station. And the soft capture system has been stowed. We see the umbilical starting to deploy. About 40% of the way so far, going pretty quickly. Should just take a couple more seconds until we're all the way connected. And then we should be getting that docking complete call out from the core here in Mission Control, SpaceX and Hawthorne. Standing by.
Dragon SpaceX, docking sequence is complete.
Dragon, we copy docking complete. To say that it's been a real honor to be just a small part of this 9-year endeavor since the last time the United States spaceship has docked with the International Space Station. We have to congratulate the men and women of SpaceX at Hawthorne, McGregor, and at Kennedy Space Center. Their incredible efforts over the last several years to make this possible cannot go overstated. I'd also like to thank Kathy Leaders and her team of the Commercial Crew Program of NASA. An outstanding job by everyone. Last, I'd like to thank the men and women of the National Aeronautics and Space Agency. This is an incredible time to be at NASA. 3 new vehicles to be flown, continuing mission in low Earth orbit, and then to the moon and Mars. We thank you again and congratulate you.
Dragon arriving. Crew of Expedition 63 is honored to welcome Dragon and the Commercial Crew Program to welcome aboard the International Space Station. Bob and Doug, glad to have you as part of the crew. Well done. Bravo Zulu.
Hello, Kathy. Thank you, Chris. Thank you, Chris.
Endeavour, this is Houston. Bob and Doug, welcome to the International Space Station after your spectacular rendezvous and docking of the first Crew Dragon vehicle. For the first time since the retirement of the space shuttle, you have completed a historic ride to the ISS and have opened up a new chapter in human space exploration. On behalf of the flight control teams here in Houston and in Hawthorne, California, and to our SpaceX colleagues, bravo on a magnificent moment in spaceflight history and on the start of a new journey that has changed the face of space travel in this new era of space transportation. Bob and Doug, good luck, and we look forward to working with you on board.
Dragon, SpaceX, Bob and Doug, we here at SpaceX are honored to have been part of ushering in this new era of human spaceflight. On behalf of the SpaceX and NASA partnership, congratulations on a phenomenal accomplishment and welcome to the International Space Station.
Well, thank you, Anna. We appreciate all the good words and everyone thanking us, but it truly was a magnificent effort by the entire team, the SpaceX team, the NASA team, and a team across America who was able to pull this off and bring human spaceflight again to our nation. Thanks for everything. Happy to be aboard.
And Dragon, SpaceX, with that, ground will be enabling hardline power and comm connection shortly. You are go to doff your suits per procedure 4.012. We will be configuring your video to go external shortly, and we have one request for Bob's suit doffing when you're ready to copy.
We copy all. Go ahead for Bob's suit.
During your approach suit leak check, we noticed Bob's suit pass with a lower PSID than his previous vehicle and O&C checks. We still had plenty of margin to support you in a depress, but in order to rule out potential hardware issues, when Bob is doffing, after he opens his structural zipper, check all 3 bladder zipper heads to see if any are partially closed. It is possible that if the head is backed off slightly, that the white tooth is partially visible or a small gap can be seen between the end of the zipper head and the gasket end. Please report observations.
Copy. Bob will take a close look at his zippers when he doffs, and he'll get doffing first, so we'll let you know as soon as we see something or if we see something.
Great. Thank you so much.